Yeah, okay, sure. Yeah, okay. Hi, Esther.
So, am I audible?
Yeah, please.
Okay. Good evening, everyone. We have joined for this call to attend a talk session on 3D printing technology in the construction industry as a part of talk series conducted by IHRD Tarang, hosted by College of Engineering, Chengalur. Tarang is happening offline from 2nd to 6th of this month. I welcome each one of you to IHRD Tarang. So today, about today's session, it is conducted by Tvasta Manufacturers Solutions Private Limited, Tamil Nadu. Tvasta Manufacturing is a deep technology startup from IIT Madras. The 6-year-old startup has already created many of India's first projects in the area of 3D construction printing. So today we have Mr. Ashwin S., Twista's Sales and Marketing Associate as our speaker. We welcome you, sir, and I invite you to take over the session, sir.
Thank you. So hope I audible to everyone.
Yeah.
Yeah, okay. So good evening all. I hope everyone like know what is 3D printing, and as Esther told, we are into this industry for past 6 years, and we are one of the leading India's leading market thing in concrete 3D printing. So I'll be giving a brief of what we do in India as well as about 3D printing technology in construction industry. Give me a minute so that I can share a screen. Uh, can you give me authority to share the thing, Esther? Sure, sure. Please take a time. No, sure. So meanwhile, let this presentation be like some interactive sessions, so that feel free to ask question regarding the technology, and like anyone having an idea of what is 3D printing or anything, something like that. Guys, be some interactive session. Let it be like interactive session so that you can gain some knowledge about the technology. So if not, no issues. I will be giving an idea of 3D printing technology. Okay. Sorry, come again. Yeah, okay. So you want me to start the presentation without sharing, right? Okay. But I guess if I'm not presenting, people couldn't understand what I'm trying to say. Okay, no issue. I'll start anyways. So yeah, good evening guys. So Tvasta is a deep technology startup. So our predominant focus is on construction 3D printing. So there are different types of 3D printing technology available in market. So we are focused on construction 3D printing where we use concrete as our predominant material for printing modules or structures, whatever you want. So let me give a brief about 3D printing. What is 3D printing technology? So 3D printing is a process, manufacturing process, where the material is deposited in the layer by layer basis, so that the entire structure or final model will be attained at the end of the process. So the materials and the strategies will be varying for the different types of 3D printers. So there are different types of 3D printers, namely FDM, DLP, SLS, SLA, and concrete 3D printers. So these are the varieties of 3D printers where the materials and the strategies will be varying, but the process flow is same for all the types of printers. So I'll be giving a brief about construction like concrete 3D printers where we are working on it. So these printers are available in market in large scale, and Tvasta is one of the leading market leaders in India, and we are trying to push our printers as well as we are in the yeah, okay, thank you. No, it's not enabled, Ashwin. Okay, okay, so yeah, so our vision is to like uh, we need to bind all our technology and machine material software as a single component and provides an end-to-end solution to the customer or a needy, like whatever the problems faced by them during the construction thing. So our aim of the company is to building platforms and application and apply our solutions using 3D printing technology in the field of construction and try to automate the things in the field of construction. So you know that the comparing to other field and the automation. So construction is the only field which is very lagging back compared to other things. Like you can see a manufacturing of car or manufacturing of vehicles and manufacturing of other products. In fact, in the market it is very automated, up to date, but in the field of construction we are still following the traditional method, and the minimal amount is automated compared to the other industries. So we are into the phase to minimize that point, and we are into phase to automate the construction thing and automate everything, so that we will be increasing the efficiency as well as we will be increasing the productivity rate compared to the traditional one. So as I told earlier, what is 3D printing? So this is a manufacturing process. So there are two types of manufacturing process, where one is additional manufacturing process and another is subtractive manufacturing process. So 3D printing comes in an additive manufacturing process, where, for example, you see in the subtractive manufacturing process, you take an example as an uh, wood carving industry, where the doors or windows or any sculptures which is made by wood are subtracted from the actual wood piece, and we attain the final process. So that is called a subtractive manufacturing process, where we are into additive manufacturing process. We add materials in the layer by layer basis, so that we will get an 3D model in the end of the process. So let me go to like what we build in our factory. So we build machines, materials, and software, and we have a separate printing strategy. So where we give an appropriate plan, execution plan, or end-to-end solution to the customer or the like who one would needs the thing. So when we talk about the machines, we have a number of machines, namely concrete offset 3D printer, concrete onset 3D printer, robotic static printer, and robotic arm and crawler printer, and robotic arm and track printer, and pole printer. So these are the printers right now we have, and we are working on the thing. So these printers have a separate application process, so it depends on the thing where the customer needs. So this is a completely manufactured in India, and this is a completely make in India product. And talking about the material, so we have a specially engineered material, which is specially engineered by our material team in our factory. So this is an in-house product where the material is manufactured in such a way that it can adapt wherever the product is need to be placed or need to be print. So post that I'll be resuming here, so that you couldn't get what I'm trying to say if I'm not presenting. So I'll wait for some time so that I get some approval for present the thing, so that you can understand. If not, you couldn't follow what I'm trying to say. So let us wait for a few more minutes. Meanwhile, Ashin, you can just call her and make this thing. Okay. or else I'll share the thing. You can present it from your thing, from your official website, official mail, something like that. Is that possible from your side? Sorry? Yeah, so Arjun Manoj is a new host, it seems. Uh, you can contact him to try, ask him. Yeah, yeah, it's audible. Who is this? It's audible, Ashwin. Okay. Yeah, okay, then let me know after the thing sorted out so that I will be joining. Okay. Okay, I'll then share the link with you in WhatsApp. Just check. Ashwin, kindly check your WhatsApp. I share the thing with you.
It's a blank string.
No, Ashwin, it's a black screen actually. Yeah, yeah, it's visible. Okay, please go ahead. Go to the homes. Oh, okay, please. Yeah. Yeah. Okay. Cool. So hope I can. I'll start the presentation from the beginning since there are new joinees. I will start the presentation from the beginning. Okay. So hi, good evening all. I am Ashwin from Tvasta Manufacturing Solutions. Hey, the presentation got stopped. Yeah. Okay. Yeah. Yeah. No, it's a screen mirror, bro. Like my face is only visible. The presentation is not visible. Okay, cool. So Tvasta is an IIT Madras startup company. So we started in 2016, and we are in the R&D phase for past 6 years, and we emerged as an separate organization in the year 2020. So our ultimate aim of the company is to build platforms and afford homes in a very in a sustainable manner to Indian public, and as well as to apply the 3D printing technology, construction contribute 3D printing technology in the field of construction. So our vision is to combine all three predominant thing which we manufacture: machines, material, and software in a single thing, and we provides an end-to-end solution based on the problem we face in the day-to-day life. Next slide, please. So these are our co-founders. So all three are from IIT Madras. So did their bachelor's in mechanical engineering and the masters in the respective department from product design, instrumentation, and thermal engineering respectively. So CEO Aditya VS and COO Vidya Shankar and Parivartan as CTO. Next slide, please. So as I said earlier, 3D printing is a technology. So 3D printing is a manufacturing process. Next, like double next click. So 3D printing is a manufacturing process where the printer extrude the material in such a way that it forms a layer by layer basis and forms a final 3D model or 3D structure what we need and what we feed to the printer. So that is what the 3D printing means. So you can see the previous slide, please. So you can see a graph over here. So this is to compare that the construction industry with other manufacturing industries and other service industry and production industries, where those industries have an automation of like we can see a rapid growth in a period of years, where the construction industry still below the line. So we are there. We are here to fill the line, fill the gap between the above line, and we are in the phase to automate the entire construction industry. Next, please. So what we build in Tvasta. Next, please. So we build machines, material, software, and end-to-end solutions. Click please. The fourth click. Next. Yeah. So when I talk about a machine, we have an offset 3D printer, on-site 3D printer, and static robotic arm printer, and robotic arm and crawler printer, and robotic arm and rail printer. And adding on to that, we have a pole printer, which is an initial stage in our company. So talking about the material, so we have a specially engineered material which is manufactured in house, and we have separate material team in our factory, so that they will engineer the material in such a way that based on the location the project is going to happen, and the material is very easily adaptable based on the geographical areas. So talking about the software, we have an own custom software designed by our own software engineers, and we have a separate software automation team in our factory. So this is a completely make in India product, and all three machine, material, and software are a make in India product. So talking about the printing strategy, we provide end-to-end solution starting from the basement to the. Yeah, I got. Thanks. I'll present. Thank you for your service, bro.
Sir, your mic is mute.
Yeah, I'm audible now.
Yes, sir.
So the screen is visible for you guys.
Yeah.
So yeah, so talking of the printing strategy, we provide an end-to-end solution starting from the, for example, we need a construction house. So we provide design starting from the foundation till the end, till the MEPs, till the conduits, everything we will give an end-to-end solution. So what are the advantages of concrete 3D printing? So as I told earlier, 3D printing technology is a faster manufacturing process. So obviously it is a faster construction, less waste, high productivity and capability customized. So talking about the faster construction, for example, we did an India's first 3D printed house, which was constructed in the duration of 21 days. So it is sometimes like it is somehow 25x faster than the conventional one. And since it's a machine, the wastage of the profit and the efficiency of the machine is very high, so the rate of the construction and the wastage is reduced, and as well as the productivity increases. So we say the, like ideally we speak, right now we face only like negligibly 1% of waste during the manufacturing process, as well as in the field of production, in the perspective of productivity, we produce around like, how to say, in cubic meters, around for an understanding, we can construct an entire 500 square feet of house in a duration of 5 days or 4 days, and capability customized. So our ultimate advantage here is designs. So whatever design you think in your mind, how complex it is, we can print. So that's the ultimate advantage of 3D printing. What, not only in construction 3D printing, it applies in all 3D printing technologies. So capability customization is one of our major advantage. So the ultimate thing is whatever you think in your mind, we can print. So how complex it is, no matters, printer can print. So this is our basic facility which we have earlier. So you can see it like R&D. So the printer shown here is an R&D printer, which was our first version of printer. So this is our production level printer. This is our first production level printer. So using this printer, we constructed an India's first printed house. So right now this printer got dismantled, and we have a second version printer. So this is a gantry based printer. So right now this printer is based in our factory in Chennai. So this is an offsite printer. So we have two strategies of building structures, building buildings, anything. So one strategy is offsite strategy, where the printer print the modules in the factory, and we ship the modules from the factory to the site, and we'll integrate the modules in the site. So this is an offsite strategy. So another strategy is onsite strategy, where our printer, we will bring our printer to the site, and we will assemble the entire printer over there. And our entire printer, like our printer is capable of building an entire structure, or print an entire structure in a single go. For example, you can print a G+2 structure in a single go using an on-site printer. So this is an on-site printer. You can see a couple of members sitting down here. So this is to show you that the comparison of the size, how big scale this printer is. So this is our robotic arm printer. So this is a static robotic arm printer, where this robotic arm is mounted on the ground, and it can print. So this printer is used for the complex level printing, complex structures. It can print very complex print designs in an easy manner. So this is a robotic arm and crawler printer, where the robotic arm is mounted on a crawler, and this is a kind of mobile printer where the printer can move and print. So it obviously increases the print volume, build volume, print area. So obviously productivity and efficiency increases here. So here, yeah. So this is our whole printer, where right now this printer is on a process, and we will be soon doing a project using this printer in Chennai, in IIT Madras. So yeah, so this is a wall module of our normal structure. So you can see MEPs are done in this wall module. So for your understanding, I'll say this is our all most of the wall modules are hollow kind of structures. So that this wall module act as an insulator for temperature, like temperature and water seepage, etc., etc. So during the design phase itself, we will be designing such a way that our printer will give an space for inserting an conduit for electric boxes or switch boxes, or plumbing pipes or something like that, etc. So if not, the designer forgot to give a place give a spot for the conduit to fit an electric box. We can just cutting a piece of cake after the printing post printing process, and we can just insert it wherever we want. So it can be done either this way or that way. Yeah. So this is our India's, like this is an first print which we made in 2018. So this is our first R&D structure, and still it is in the IIT Madras. So this is India's first 3D printed house, which I spoke earlier. So this house was constructed in duration of 21 days, and the entire construction of this house videos posted in our YouTube channel, so you can go and check it out for your further clarifications. So these are the interiors, few interior shots of our house. So this is inside our IIT Madras campus, and this is about 450 square feet of area, and this is entirely 3D printed except the roof and the foundations. So these are some sanitary blocks. We constructed few sanitary blocks for Indian Air Force in Jaisalmer, and this is a doffing unit. So this is something interesting we did last year, like during the second wave of COVID. So you know, like how was during the second wave of COVID in Tamil Nadu. So during that period, COVID workers, the frontline workers were felt very difficult to change their clothes or change their utensils and their aprons from the COVID ward. So we designed this doffing unit where you can see two compartments over here. So this was an offsite strategy where the entire unit was printed in our factory. We done everything, MEP styles, everything we done, and we just left the, like we just transported this structure and we just install over there. And hardly takes 5 minutes to install this entire structure. So you can see two compartments over here. The first compartment is to change the clothes, and after the changing of the clothes can be thrown away by the dustbin, which is placed over here. So you can see a dustbin over here. So this is an slot. This slot can be used for the throwing of clothes. So the doctor or like COVID workers can go to the second compartment so that they can take a bath and they can leave outside. So there is no need to come again for the contaminated area over here. So this is something interesting for me as well as our company. So this unit was constructed in the duration of 5 days, entirely including the foundation to the MEPs to everything, tiles, everything. So this is an guest house of about 1,500 square feet in Chiloda, which is in Gujarat. So this we did for Indian Air Force for Airman guest house. So this, for your information, this area comes in a seismic zone 4, which is a high earthquake prone zone area. So yeah, we designed in such a way that it can withstand those kind of earthquakes over there. This is a facade wall. So this design is something inspired from the Rajasthani architecture. So we did facade wall for BPCL, Bharat Petroleum, for Krishnapatnam, Andhra Pradesh. So this is an India's first independent bus shelter. We did this for Godrej construction in Mumbai. So this shelter was currently installed in Vic Road in Mumbai. So you can see in fluidic finish, and this is a monolithic structure. So you can see in fluidic finish over here, and there is no support for the roof. So this is a recent project we inaugurated in the month of November. So we did this project for India Cements. So and on the behalf of the 70th anniversary. So this was India's first independent monument. So its height is about 21 feet, and it is in Chennai, obviously. It is located in the India Cements headquarters. So it was inaugurated by like central ministers. So this is a very recent project which is inaugurated for JRSC in Kolkata, Garden Research Ship Building Builders. Yeah.
ഒരു സൂം മതി എന്തായാലും കയറി സർട്ടിഫിക്കറ്റ് ഉള്ളൂ. കാരണം എനിക്ക് നെറ്റ് ഇല്ലത്, എപ്പോഴാ കട്ടാവാന്ന് പറയാൻ പറ്റത്തില്ല.
This meeting is being recorded.
വാട്സ്ആപ്പ് ഗ്രൂപ്പിൽ കയറണോ? ആതിരൊക്കെ ഉണ്ട്. ആതിരൊക്കെയാണ് ഉള്ളത്. എന്തിനാ നമ്മള് കയറി? ആതിരൊക്കെ ഉള്ളത്. നമ്മുടെ ആതിര എല്ലാത്തിലും കയറുക.
Yeah, I've muted her.
Yeah, host can do that, I guess. Host can do that.
Yeah.
So yeah. And guys, till now you are following me, right? Till now you can get the thing what I'm trying to say, right?
The recording has stopped.
Yeah. So this is a recent project we did for GRSC in Kolkata. So we inaugurated this project in the, I guess, on New Year. Yeah. So this is a modular site office, and this was constructed in the duration of 1 week, including the MEP. And this was done in offsite strategy, where we printed these modules in
This
our
meeting is
factory
being
and
recorded.
shipped these modules to the Kolkata and India over there. So this is our way forward projects. So we will be working in future. So we have an idea to introduce an cavity based roof and cavity based or foundation or flooring. So this acts as an insulator, both as a sound as well as a water seepage. So we are working on that, as well as we are working on to integrate the column with the wall module without during the printing process itself. So I can see a column over here and a cavity based roof or ceiling and cavity based flooring over here. So this is our fluid exterior finish, which can be very easy, which is very easy to achieve using 3D printing technology. So we are working on this as well for our exterior finish. So this is one of the interesting project we are working on right now. So you can see in hollow spaces over here. So we thought of why can't we change static standard windows of rectangular square shaped windows to a circular or cuboidal amoebic designs of windows. So we are working on that. So and again here we can fill whatever material we need as an infill over here for filling this gap. So this is one interesting thing we are working, and this is another project we are working in ECR, East Coast Road in Chennai. So the idea here is to integrate the wall with the staircase during the printing process itself. So it's not printing the staircase separately and the wall separately. We will be printing both the wall and staircase simultaneously. So again, this is a G+1 structure. So this is an only very interesting project. We are right now working in IIT Madras. So this is a G+1 structure, which is a guest house for IIT Madras. So as IIT Madras is concerned, so it's in a reserve forest area where the forest where we couldn't cut any trees. And our ultimate aim is not cut on any trees inside IIT Madras, but our structure should be built over there. So what we thought is to install our mobile 3D printer over there or a robotic arm and crawler printer over there, so that the printer can move in and around the forest and print the entire thing. So you can see the design itself, the building is coming emerging from the trees or the forest itself. So this is one interesting thing we are doing, and again this is an India's first green building, 3D printed green building. And these are our possibilities of 3D printing technology and on-site printing. So we can see possible villas on the right side, and you can see a possible G+7 structure over here. So this can be printed using our 3D printers. But right now we are working with framing some policies with governments so that we can print G+2 structures, G+3 structures. So these are some architectural and structural elements which can be very easily printed using 3D custom 3D printers. So these are some furnitures and planters. So this is our planters, and see you can see the exterior designs, planters, seaters, and these are the structures which doesn't need any support or column kind of thing. So you can see an clock based seater over here, and you can see an column over here. So yeah, so you can see two unique possibilities of an finishes, which is a dome. So on your left side it's a dome kind of structure, on your right side it's a column kind of structure, and in both have two unique finishes in the exterior. So we have certification memberships with ISO and IGBC, and also we have a member in CIA. So these are our awards and collaborations. So we have collaborated with Ministry of Housing and Urban Affairs, CBRE, IIT Madras, IIM Ahmedabad, IIT Allahabad, and IIT Roorkee, IIT Kanpur, India Cement, State Government, Godrej, and so on. So we have collaborated with most of the institutes in India, and we have a lot of awards, but we didn't update it in the slides. So these are recognitions and presses like for our IIT Madras houses. where our Narendra Modi ji mentioned in his Agnipath program. And this house was inaugurated by Nirmala Sitharaman ji. Since this house was constructed during the COVID season, we couldn't inaugurate it in the physical manner. So she inaugurated in the virtual manner. And few Indian government dignitaries visited our house recently. So this is our core team who built this India's first independent house and other structures. So we have an 50 talented engineers in our team. So that's it from my side, and you can ask any question you want, any question in your mind regarding this presentation, what I presented right now. Please go ahead. The questions. So you are asking about residential projects, right? So yeah, to answer the question, I'll say right now we are working on the selected pivotal projects, not only for the private projects. We are working on selected private projects where it comes in the government sectors and private sectors. Not only the private sectors we are working. So why we are not coming to residential thing means, so right now our price is comparatively 20% higher than the conventional one, since our material cost is very high. So in the period of 2 years or one or 2 years, we will be giving a competitive price with the conventional one, so that we can get into the residential projects. And for information, right now, as I said earlier, right now we are working with Indian Urban Housing Affairs to frame some policies, to make some standards. Since this technology is very new to India, there is no certain standards and there is no certain policies like we have for conventional. For example, you have you have to get approval for CMD, something like that, for construction of normal house in the conventional manner, right? So for 3D printing technology, there is no other policies or standards are fixed or framed. So we are working, we are collaborating with government, we are working with government to frame such policies. So after we get that PAC certificate, we frame that certificates, we'll be working for residential projects. I hope I answered the question. Guys, please go with like questions, whatever you want. Which platform is best for doing 3D modeling? You are asking about, can you unmute yourself and ask the question so that I can get clear about what you are asking? Kiran Koshi.
Hello, sir.
Yeah, hello.
Hello, sir. I have a question.
Yeah, please go ahead.
Sir, is the 3D building as strong as the conventional building?
Come again, your voice is not clear. Come again, please.
Sir, now, am I audible now?
Yeah, please go ahead.
Hello?
Yeah, it's audible. Please go ahead.
Okay. So, is the 3D buildings as strong as the conventional building?
It's like, yeah, since we have an special engineered material, so it is 2x stronger than the conventional one, I can assure that thing. But I couldn't give a proof for that, since we don't we did a proof of concept for our side, but it does not exist for more than 10 years. So but theoretically it is 2x stronger than the conventional one based on the test we conducted on our structures. So yeah, since like I said earlier, our material is like you say, you need to construct in a structure in a seashore, or you need to construct structure in a lake, or you need to construct structure in Thar Desert in Rajasthan, or you need to construct structure in northeast where it's a heavy rainfall region. So it depends on the locality. It depends on the geographical area where the structure is going to be. So our engineering team, our material team will be specially like engineer the material in such a way that the material will get adapt to that locality, get adapt to that geographical area, so that it will withstand the wear and tear of that atmospheric area. So it obviously increases the strength, durability, endurance of the structures whatever we build. Understood?
Yes, sir. Thank you, sir. Thank you for clearing my doubt. Thank you.
Yeah, thank you. Guys, feel free to ask the questions. I'm here to clarify your questions. Please go ahead with the questions. Uh, okay. So as of now, as I mentioned earlier, it's 20% higher than the conventional one. So for you say, for example, you need to construct a house in like in a conventional method. For it, it takes around 1 lakh or 2 lakhs. For just for example, it takes 20 lakhs for like 20% higher, not 20 lakhs. 20% higher than the conventional one. Since the technology is new, the material is new, everything is new, and we are predominantly focusing on the premium construction. So like all the materials used in the process during the construction are the premium products. So obviously the cost will be high. When we come to the residential projects, it will based on the customer, and based on the design, the cost varies. As I said earlier, we give an end-to-end solution. So starting from the design phase, we give a solution, right? So based on the designs, how complex the design, the cost varies. So we couldn't given numbers, exact numbers what you're asking. Which software platform? Right now for designing our printers, we use Fusion 360 software, and yeah, AutoCAD, Autodesk, and Fusion 360 are used by our mechanical engineers, and then and other our printer software is our in-house software which is manufactured by us. It's not available in the market. And what else? Yeah, that's it about the software thing. And sorry, is it economical than a man-made or ordinary construction method? So for the answer that question, so for example, you need to construct in a bulk of bulk structures. For example, you need to construct 100 units or 40 units, 50 units of some structures, which will be very economical compared to the conventional one. But if you need to construct only a single structure or couple of structure, it will be costing higher than the conventional one. So it depends on the numbers as of now, but in a couple of years we'll be giving in competitive price, and we can give a price less than the conventional one. We are working on that. What motors do you guys use for the control of the printer? Printer motors. So we have servo motors for those controlling of the printers. Chat.
Is there any limitation for 3D printing?
Limitation in the sense right now the cost is limitation for us. So what we faced as a like limitation means the cost is one thing, since it couldn't afford by all the people in our area. So we are working on that to reduce the cost perspective, and ideally the limitation will be we like it took 6 years of R&D. After that only we can achieve this kind of success very easily. So I think that is one of our limitation, where it took 6 long years to achieve this kind of technology. Right now what we are working on that now. So much material cost for building a 3D model. Again, as I said earlier, it depends on the model where it is going to be placed and where the model is going to be built. So based on that, material will be varying. So based on that, cost will be varying. Come again. Yeah, so right now our entire technology is a patented technology. So in future we will be distributing our technology all over India, so that printing of structures can be happening all over India, and we will be having a franchisee partners over there, joint ventures over there, so that they will be owning a technology there. They will be doing projects over there using our technology. So we will be getting paid for that. Understood? But it could affect normal people job in high rate, like construction based working peoples. No, to answer the question, Pranav, we will train the people who are working in the construction industry. See, as year passes, the people in the field of construction should be get educated, should be get automated. If not, they should. It is not that they should be like be working in the conventional traditional way, right? So we will be training those peoples to operate our printers so that they can work with the printers and they can print such as whatever they want. These printers are changing based on materials. No, printers are standards. Our material will be changing based on the structures what we build. I'll present a video of a thing of a recent that monument thing, so that you'll get some idea about what we do right now. Like I'll show a video right now. The screen is visible. Video is visible or what? Okay, let me show.
അതെ ഈ സാധനമൊക്കെ വരുന്നത് ഈ ടോക്ക് ഷോയുടെ എല്ലാം പരിപാടിയിലും ഓരോന്ന് കഴിയുമ്പോ ആ പുള്ളി എല്ലാം ഇടുന്നുണ്ട്.
So you're on mute.
Sir, are you talking? You are muted actually.
So you're on mute.
Sir, Ashwin sir. Ashwin sir, can you hear me? Sir, you're on mute actually.
Yep. Okay. So you didn't hear what I told in the during the video.
Yeah, we couldn't hear it.
Okay, so I was explaining about that thing what we do, like prototyping will be happening. Post prototyping, the simulation things will be happening for the strengthening, identifying the strengthening process, and post simulation process, everything. After the post printing process, will be like this is a steel mesh or iron mesh, which is placed during the printing process, right? You can see in the steel mesh is placed over here manually. So this is an horizontal reinforcements where this is placed during the printing process, and post printing process will be giving a vertical reinforcement, uh, and I'll be showing the vertical reinforcement in this video. So this is to increase the strength of the structure. So other than that, nothing much. So you can see, and you can see the material is this is a nozzle kind of setup. So you can see the material get solidifies, get hardened the moment it gets extruded from the extruder. The moment you extrude from the nozzle, you can see the material is something like in a defined shape, so that it does not get collapsed based on the load bearing of another layer adding on to the adding on. So we specially engineer this material to get solidified the moment extrude from the extruder, right? So based on that, the material, the below layer, the beneath layer will not get collapsed, and which can bear the load of the upcoming layers, which is going to print over on it. So this we are adding this sand thing for support thing, which is since this is a twisted and slanted steep kind of more design. So we are adding this sand for some supporting purpose. So we printed the structure using our robotic arm and static concrete based printer. This will be how it is assembly and how the project is executed in on the site. So here we are checking the level of the thing where we are going to place. So these are the vertical reinforcement which I spoke earlier. So our module will be inserted in this steel iron rods and will be grouted using a grouted material. So you can see the module is inserted over in the iron rod, right? So this is an offset strategy. So this is about this monument. This is how this is how we execute projects. So we will be grouting materials inside throughout the structure so that it will get stable, and it increases the strength of the structure whatever we build. So this is what we execute projects, and might be you have some questions based on the video you've seen recently. You can go with the questions. Any other doubts regarding this technology, or any other doubts regarding this video which is seen now? Okay. For this structure, so ideally speaking, for this structure, we took around 2.5 weeks, 2.5 weeks to 3 weeks, ideally, including the foundations, curing period, everything. Okay, can we use 3D printing technology to make a foundation for building? Yeah, we can. So right now, our projects we are using 3D printed foundations for the projects. Oh, one thing which one is faster than is it? Gantry printer or robotic arm printer. So based on the structure what we are going to print, it depends. So both printers are the like rapid printers only. It can print rapidly. But the thing is the complexity, the shape which you are going to print, and where like the robotic arm can print in this direction. So let us assume this is an palette where we are going to print. Our printer can print that it can lift the nozzle over here and can print in the palette over here perpendicular direction, but in gantry we couldn't. So gantry will be printing in the base of the gravity direction only. So it depends, we couldn't define which is faster. It based on structure what is printing. So yeah, it based on structure what we are going to print. This process is economical, as I said earlier. This based on the structure we are what we are going to print, and yeah, it depends economical based on the units, number of units we are going to print. Again, how much time will be taken for building these 3D models? 3D models, it's on 3D structures. So these structures, so ideally speaking, for example, right now we are working with TNCA, which is in Tamil Nadu Cricket Association ground, CSK ground, which is in Chennai. So we are working as a boundary wall project. We are working the boundary wall project. So its height is about 3 meter. The wall height is around 3 meter. So it hardly takes 2.5 hours to construct two units of wall, which is 3 meter, 3 meter, 6 meter wall. Hardly takes 2.5 hours. So this is how I can explain. So this is how we can assume the timings of the buildings or structures, whatever we built. And for further updates and what like you, if you are interested and if you are keen about this technology, you can follow us on social media webpage and social media handles, where we'll be posting our regular projects and printer updates on that, so that we'll be getting updates on what we do there. Any other question? Sorry. Yeah, let me take a look. Pranav, is the material heavier than the normal material used now? Heavier in the sense you are asking about density or weight, or what? In what aspect you are asking? Just unmute yourself and ask clearly, so that I can answer the exact question what you are trying to ask.
Hello, can you hear me?
Yeah. Please go.
Yeah. Can I speak in Malayalam? That will be easier for me to talk.
I couldn't understand Malayalam. If someone
Yeah.
can translate, means I'm okay with that. Anything is fine. Yeah, please go ahead.
ഓക്കെ സോ ഇപ്പോഴത്തെ ബിൽഡിംഗ് എല്ലാം നമ്മൾ സാധാരണ സിമെന്റ് വെച്ചാൽ പറഞ്ഞു കഴിഞ്ഞത് അപ്പൊ ഇച്ചിരി സ്ട്രോങ്ങും ആണ് ഇച്ചിരി വെയിറ്റ് ഉണ്ടല്ലോ അതിന്. ഇപ്പം ഈ ഇപ്പോഴത്തെ നമ്മൾ 3D പ്രിന്റ് ചെയ്യുന്ന സാധനങ്ങൾ വെയിറ്റ് കുറവാണെങ്കിൽ നമുക്ക് ലൈറ്റ് ആയിട്ട് യൂസ് ചെയ്യാമല്ലോ. ഇപ്പം ഒത്തിരി ഇപ്പം ചിലയിടത്ത് ഈ ബേസ് ഒക്കെ മണ്ണൊക്കെ ഒലിച്ചു പോകുന്ന സ്ഥലങ്ങളിൽ ഒത്തിരി വെയിറ്റ് വെച്ച സാധനം വെച്ചാൽ ചിലപ്പോൾ ഡിസാസ്റ്റർ സംഭവിക്കാം ഒത്തിരി വെയിറ്റ് കൂടിക്കഴിഞ്ഞാൽ. ഇപ്പൊ 3D പ്രിന്റിങ്ങിന് വെയിറ്റ് കുറവാണെങ്കിൽ നമുക്ക് വേണമെങ്കിൽ ഈ അധികം ബേസ് ശക്തിയില്ലാത്തടുത്ത് ബിൽഡിംഗ് സംടൈംസ് അതുപോലൊക്കെ യൂസ് ചെയ്യാമല്ലോ വെയിറ്റ് കുറവാണെങ്കിൽ. അപ്പൊ മണ്ണിടിച്ചിലൊന്നും ഉണ്ടാവാതിരിക്കാമല്ലോ.
Okay. So to answer that question, I have mentioned that we did a project in seismic zone 4 for Indian Air Force in Chiloda, which is a guest house project. So it based on the location geographical, this material will be getting adapted to that thing. And to answer the weight or something you asked, so for that question, as I said earlier, we are doing a project for boundary wall project for TNCA, which is a 3-meter wall height. So this one wall module weighs around about 2 tons or 2.5 tons, which is heavier compared to the conventional one, where there is no brick involved in the construction phase where we are working on it, right? So obviously the weight will be higher than the traditional one since there is no brick involved. Understood? So to briefly elaborate, let us take that Chiloda Air Force guest house. So which is a monolithic structure where there is no much joints compared to conventional one, where you will be constructing using bricks. So there will be n number of joints in the conventional method, right? So if there is an earthquake or something, if there is a movement in earth, there will be a collapsing. That's why the buildings are collapsed. Since there are n number of joints, if any one joint get collapsed, the entire building will get collapsed, right? But here it is not possible since it is a single structure. There is no joints. It is a single structure, so that if even earthquake happens, the structure get shake, and due to the heaviness, due to the stability at the center, it gets stable and it does not fall. The principle, like you know that heavier weight at the bottom and weight at the top and less weight at the top, it's a stable thing, you know, so that our structure will not get fall, or our structure will get adapted to that shake and movement or something like that. So yeah, it's heavier, the material is heavier than the conventional one. I hope I answered the question. Since we use only the concrete, nothing is added, only the concrete. Any other questions, please? Ashwin, if not, we can wind up the session, right? Yeah, okay. Yeah, thank you. Sorry? Yeah. I have done a number of presentations to Kerala colleges, Kerala. I have done a number of presentations, and we are working on few projects in Kerala. Probably we'll be doing soon. We'll be working in Kerala soon. Since our co-founder is from Kerala, for information, our co-founder like CEO Aditya VS from Wayanad. Yeah, so all our founders are from different states. So Aditya VS CEO is from Kerala, Vidya Shankar COO is from Bangalore, Karnataka, and Parivartan Reddy CTO is from Andhra Pradesh. And we have a base at Chennai. Yeah. Yeah. Yeah, thank you.